What's going on today, gentlemen, ladies and gentlemen? Got a Rheem inverter for you today, and get this, the part we end up needing 16 to 20 weeks on back order if they can get one, and the unit's only 7.5 years old. So everybody knows I'm a train guy. Train XV runs circles and circles. It's got this inverter from Rheem lapped 20 times over around the track, but hey, Rheem inverter, as far as I'm concerned, that thing's fake news. Enjoy the video. So what's going on, guys? What a start to the day. The Rheem inverter 17-seer Eco Nest thingamadoodle. Seen them, haven't worked on very. It's been a while actually. This thing's changed a lot since the last time I saw one. But we're getting an L16 fault on this thing, and obviously they don't have a service fax manual in the outdoor unit as they should, in my opinion. But I mean, Train puts a nice thick one with about all the information you need in it, but Rheem, unless it's lost or they don't know where it's at, I don't know, but I've got it online. So L16 is an inverter fault, discharge line temperature fault. Power cycle the system, verify all the lights on the inverter out. You gotta wait for it to discharge. Check the UV and W output terminals are correct, which they should be. No one's unwired anything or done anything, but I'll check that. Check the charge level. So our discharge sensor fault is basically our issue. Outdoor ambient above 125, outdoor ambient below 0, allow unit to cool down or allow it to heat up. It's 60 degrees outside, so that's not going to be a problem. Check the charge level. Check the thermistor continuity. It's a 10K thermistor, so just got to figure out which one of these is it. So get the meter, get the needle leads out, and see what we can come up with. I don't know if it's still that way or not. We had one of our sales guys that we call them project managers. He doesn't work here anymore. The company he worked for a while back, he had put one of these on his house, and there was an issue that would, in real cold weather on those things, and I called tech support, that if it got below real cold temperatures, it would actually shut the compressor down on the thing, which I think is, and go straight to emergency heat, which I think is ridiculous, because it was like 28 degrees outside, 28 degrees outside both times we went out there, and it was the same thing. Get on the phone with tech support. Yeah, your crankcase heater or the compressor temperature, you know, and you go back out there in warmer weather and check it, the charge was fine, but they said that, yeah, it'll shut that compressor off, which is kind of mind-boggling to me why you would want to do that. The needle leads out at that temperature. I can understand maybe below 20 degrees or something like that, but 28 degrees, I mean, my heat pump works just fine at 28. My heat strips are actually locked out on my system at 25 degree outdoor temperature, so anything above 25 I'm not running heat strips, and that heat pump works just fine. 30 degrees outside, 28 degrees. Set it for 69. I don't run it real hard, 68, 69. Wake up the next morning, 68 degrees in the house and 28 degrees outside. But anyway, technology is a fickle thing. So let's figure out. So our discharge thermistor should be on our discharge line, which, yep, right there. If you look right above that filter dryer, you got a pressure switch, and on the other side of it just back that yellow wire on the other side. I'm not going to take the top off. You'll see a little thermistor, 2 black wires. So let's trace it out and see which one of these plugs. I mean, the wiring diagram says sensor, but I don't see it where your component codes say sensor, discharge line, thermistor. But over here, I don't see it saying sensor anywhere on the diagram. So we're just gonna hold on. All right, it's over here on this other one, labeled inverter, and it's going to be a 4-wire plug with 2 wires on it. I'm going to hold on. 1, 2, 3, 4. It's labeled. Where are we at? Is this it right here? Nope, it's this one. Right there is what I'm assuming I'm looking for. The way that plug is laid out on the board, if the diagram is correct. Thermistor there, sensor here. So I'm gonna do it the old-fashioned way just to make sure I've got the right one. And we're gonna cut this zip tie. And I just like to get all my wires loose. See where this one's going back, because they all kind of intermingle in here and go back through the same hole. So let's find this one first and go back this way, and then I just typically just tug my wire and you'll see it move. That's where it's going. And sure enough, it is. So it's going to be this particular wire right here. I'll turn that up a little bit. So this is going to be our discharge sensor. There. And it's a 10K sensor, so let me pull up my 10K chart, which I usually keep 20K and 10K charts saved in my notes section in here. Or maybe it's on the other phone. And there's probably a chart somewhere, but there's like 70 pages of this manual on the phone. And I really don't want to scroll through that thing. I could go get my iPad, but I don't like carrying that thing around either. Alright, sensors there, 20K. So I keep a set of these sensor charts on my phone so I can pull them up real quick. This is a 10K chart. So let's check the resistance on that real quick. I kind of like the trains because you can just do it by DC voltage. Probably can on this one too. I'd have to find the information and read it somehow. I don't know what the output is on this thing, but you can kind of just measure your temperature and then just check your DC while it's plugged to the board under power, and it'll give you a DC voltage for whatever that temperature is, if you're correct or not. So let's on this sensor out real quick. .2. Let's go down the chart and find 14. Find my outdoor temperature first. Outdoor temperature here where we are is 60 degrees. This says 60, 61. If you want to look at that, maybe not. So 61 degrees. We're looking at 14.9. I've got 14.2. 14.2 would be about 62 degrees. So 14.9 ohms is 61 degrees, which is what I'm reading out here. Could be 62. This thing's just giving me a general temperature. I can pull out a temperature probe real quick and confirm that, but so it's telling me the chart is, I'm reading 61, 14.9. I'm going to ohm this out through the plug. I am getting 14.25. So 14.9 is 61, 14.1 is 63. So what I'm reading would be between 61 and 63 degrees, 62 and some change maybe. That sensor is reading just fine. So what I need to do now, pretty much, make sure all this stuff. That's kind of funny. I turned off the breaker to this thing, but yet I'm still getting fault code flashing at the bottom. So let's start looking for some power, because that thing was supposed to shut off. Let's check right here, red and blue. And I don't have any voltage there. 0 and 0. So that leads me to believe possibly that this particular board that's on the bottom down here, as you can see, I'm still getting a fault flash, but yet right there where my high voltage is coming in, there's no high voltage. So possibly this board runs off this 24 volts coming from the air handler, maybe. So let me figure that out real quick. We have common and R, 26 volts. So let's unplug this and see what happens. And as you can see, the fault list indicator went away. So that's kind of, you learn something. Like I said, I don't see these all the time. So anyway, we'll zip tie these wires back in. I'm going to guess the discharge line sensor is reading correct. We more than likely are going to have a refrigerant charge problem on this unit. So, and that attic up there is tight. This is an older house. It's got that real low pitch A-frame or A-roof on the top of it, and the wooden little hatch in that closet that you go into. I went up there and checked, or kind of got an eyeball on everything before I came out here, and sure enough, it's in a spot where you're going to be laying down in front of the, if I have to go up there and do a leak search, I may or may not take you with me, but I'll give it a shot. But anyway, so I'm going to cycle the power on this thing, get it back on, and we're going to check the refrigerant charge on it. Because I am, I've got this off, getting a call as well for Y, and I am not getting one for, oh, that's right, B. We got a Rheem. They energized their heating and cooling ass backwards from everybody else. So anyway, so let me get my gauges and stuff hooked up. We'll get this thing cycled and get it on, see what our charge looks like. Okay, I've got the hoses hooked up. Get the temperature probes hooked up. And as you can see, we have a large C flashing, so it's a short cycle timer, something in this thing. You wait it out. I kind of like to wait them out, especially when I'm working on something new, just to kind of be familiar with how it works, or something I don't see a lot of that, you know, you don't remember something you looked at last time a year and a half or 2 years ago. I haven't seen one of these. You don't see a lot of these Rheem units. We see a lot of Rheem and Rudd units, but you don't see a lot of the inverters and things like that. It's not from the Rheem side around here anyway. I'm trying to get this camera to kind of stay in a general location, but yeah, that gives you a little bit better view. You can push the test button, it says. Let me get my app open. There it comes. And she's fired up. Let's see what these pressures do. It's quiet, I'll give it that. It's in a second stage call, but it's not really a communicating unit. It's still all 24 volt controlled down here. They've got a Nest thermostat, go figure that, on the wall. So, I mean, it gives you more options, I would say, to install it. I kind of like the communicating, because you can go back to your thermostat, pull up your fault codes, your fault history, your run history, things like that. As far as the Train XV goes, this doesn't give you that option. So let me select my refrigerant, so it'll give me my superheat and subcooling. And there we are. So that's where we're at right now with our pressures. But I'm gonna let it run a minute, let it build up. There should be some pretty good, and it's not hot up there. And it's 64 degrees outside now, but it was warm enough. It was warm yesterday. So those pressures are looking a little low. Got a 26 degree superheat and a 0 subcool. I don't know if the sticker on this unit gives you a design subcooling on it or not. Let me check that real quick. But regardless, 8.9 subcooling is low. So maybe there's something in the paperwork that tells you, but it's not here, so you got to go through that book. I don't see anything on the sticker. I might be missing it. The print is really small, but nonetheless, we're running a 97 over a 203 with a 23 degree superheat and a 1 degree subcooling. And it's 72 degrees up there. The blower's been running for a little while, so there's some humidity and some heat in that evaporator right now. Little ants over here where I'm at. Gotta be careful. We'll let this thing run a little bit and see. There's no charging chart that I can see. Oh, there we go. Let's try that. We do have a little charging chart here. So, which one of these losing connection? This one. So, cooling mode, pressure requirements, cooling mode, subcooling requirements, outdoor temperature 55 degrees. Not sure which coil we have up there. Our air handler. Go up there and look, but roughly it doesn't give you 60 degrees. It just gives you 55, 75, 82, 95. So yeah, leave it to Rheem to be all over the place with their outdoor temperatures. Was they just put 70, 60? I can figure out the middle. So we got 55 to 75. That's a 20 degree swing, but I should have a, according to this, 5 to 7. It's a 2-ton unit. So 6-degree subcooling on this. I'm at 1. So he's low on charge. Compressor's running hot. Discharge temperature is going up a little bit and shutting the compressor off. So let's let it run a minute. We're at 1.5 subcool. Superheat still in the mid-20s. And that's not really warm air coming out of the top of this thing. Suction's up to 108. The head pressure's still at 207. Evaporator coil temperature's 34. So I guess we're going to be looking for a leak. Kind of a funny place to put a water switch. That's a little bit too late, don't you think? So we are doing a leak search. And checking the back side of that coil down the edge. And this leak detector will start getting a little faster and a little faster. Right there. As I do manual calibration on mine, and you can set that sensitivity. There it is. Faster. It's a very small leak in that. And it'll slow down once it recalibrates to fresh air. I didn't want to do a whole video of going through this whole coil, but I checked everything around this area here in the front. But that one place in the back, every time I go there, picking up speed. A little faster. The closer I get, faster it gets. Picking up speed. And that's where our leak is. Fresh air, it slows back down. I love an H10, especially if there's an outlet close by. I can plug it up, although it does hold a charge. But that's going to be it. I mean, it's a small leak. The subcooling was 2 out of 5. So it's a real tiny one. That's why I like the H10. You can kind of do your manual calibration. And there's a little test bottle on it if you want to check it. Stick it right to it. But looks like it's going to be a Rheem evaporator coil. Like, subscribe. Appreciate you guys watching. And hey, you run into equipment you don't see a lot, got to read the book and learn. And may not see one of these for another year, so I'll have to read the book again, but that's part of the job. Like, subscribe. Thanks for watching, guys. You guys stay safe out there.